In today's lecture, we are going to start recursion. So now we have come to recursion, and recursion is a very important topic, and you have to practice this topic multiple times if you want a better understanding of recursion. Now, so let's get started. Recursion. So recursion, if I give you a basic idea of recursion, recursion is basically like we have learned loops, for loop, while loop. Similarly, if you want to create a loop using function, suppose if I have a function whose name is print, okay, there is a function named print, and if I want to do for loop for I in range, suppose 5. Now if I want to print I, if I run this command, I got an error. So I can't define a function with using print. Sorry for that. I can write print num, and if I call this, I will get loop. I will get number from 0 to 4 because I have select the range of 5. And now if I want, if I don't want to use for loop, I want to use only this function to print numbers 0 to 4. So what can I do for that? For that we use recursion here. Recursion basic idea is iterating any task repeatedly using only functions. So basically recursion is a, you can say it is another type of loop in which we use function. So if I want to print 0 to 4 using only functions, what can I do? First of all, think what we have to do. We have to print our a number, and we have to define I, suppose 0, because our starting point is 0 and our ending point is 4. If I pass this I, what gonna happen? Oh, I have not written argument here. Suppose okay, I have created a variable I who stores 0. Then I pass this value to the argument I of function. Let's take a different variable here, and here also we have to a here, or nums. They should be more understandable. Now if I run this command, I got 0, but I don't want only 0, I want to print 0 to 4. So what will I do? After that I will write calling of this function inside this function. I will call this function inside this function by nums plus 1. And for that I have to write a condition if nums is equals to 5, then return. Now first let's see what happened here. Let's run this command. I got values 0 to 4. Now how I get this? So let's go one by one, line by line. First we got to I equals to 0. Okay. Now we know that we go to first this function call. Okay, so there is a function call and we have to execute print num function. Now we will go inside this function and here we have passed this value of I which is 0 to this nums. Now nums become 0. Now we will come to this condition. If nums equals to 5 means we are checking is 0 equals to 5. Answer is no, so we will not execute this if condition. There will be no return will be execute. Now we will go to second code which is a print nums. We will print 0. Now again we are calling this function, this same function inside this function by updating the value nums plus 1. Now here we are passing nums plus 1 which is 0 plus 1. So 0 plus 1 will go to nums and nums now become 1 from 0. Now it is updated from value 0 to 1. Why? Because we have passed the updated value by calling this function inside this function. So the basic idea of recursion is that we are calling that our function. Suppose, for example, there is our function. This is our function, right? Print num. It is first called with the value of I, which is 0. Now it got printed 0. Now when we came inside this function, it's again called print num with the value of updated value nums plus 1 means 0 plus 1. So it becomes 1. Now again when 1 got printed here, when the first call is done, 0 got printed. Again this function call himself again print num, again call print num by the value of nums plus 1. So 0 plus 1 is our 1. 1 is printed. Now again inside this function call himself by with the value of 2. And when this happened, we got the value of 2. And so we got 3, then 4. So basically this function is calling himself again and again until our condition become true. Then we return to the point where function is called. Now after 4, when our function call for value 5, now we will check that is the num equals to 5. In the last step our nums become 5. So yes, num will become 5. Now we will get return. We will not move to the print statement. We will just directly return. We came out this function and go to the point where function is called and our function got end. So this is the recursion. This is a basic example of a recursion. Now if I want to print inverted number, means I want to print from 4 to 0. How can I do this? I simply need to change the condition and I will keep the starting point will be 4 and I will decrease number by 1. I have changed 3 things. Updation means it will go from 4 to 3 to 1 to 2 to 1 to 0. means number are decreasing, so we will put minus here, and our condition is 0. Till 0 it will stop, or I should need to print minus 1. So when minus 1 become, it will get stop, and our starting point is 4. Now if I run this command, we will get 4 to 0. Our number got inverted. And suppose if I want to print table of 2 or any number. Suppose we are writing table of 4. How can I do that? We have to create a function. I can write product as a name of function. Now, what we need to do, think what we need to do. We basically need to print the product of a number. Uh, Take example of we need to print multiplication of 4 from 1 to 10. How will we do that? So basically we need to print our 4 into our I. I is a number which will iterate from 1 to 10, and 4 will remain same because we want to find out multiplication of 4. We will print here. Now we will call, but there are few things missing. The two things missing are the iteration, means the updation of I, and second, a basic criteria. Two things are very important in recursion. We called it basic criteria. And second thing is our, you can say updation, or you can also say recursive step. A basic criteria means, what is the meaning of basic criteria here? Is simply that you can say where our iteration of function will end, कि कहाँ पर फंक्शन जो है अपने आप को कॉल करना बंद कर देगा. तो हमें तो 1 से 10 तक करना है, तो हमें 11th पोजीशन पे करना पड़ेगा. अगर समझ में नहीं आए कि 11th पे क्यों, तो अभी समझ में आ जाएगा कोड लिखने पे. और अपडेशन ऑफ रिकर्जन का बेसिकली मतलब है यहाँ पे बेसिक अपडेशन का मतलब है कि हाउ behavior of our iteration, you can say, कि कितने नंबर तक कितना आइटरेट करना है, कहीं कोई स्टेप तो नहीं लेना, मतलब बीच में नंबर छोड़ने तो नहीं है, तो ऐसे आइटरेट करना है अपने आई को. सो वी नीड टू नाउ डिफाइन अवर बेसिक क्राइटेरिया एंड अवर recursive steps. Now how we will do that? For basic criteria, or suppose first we will write for our basic updation. How will we done that? We need to update I value from 1 to 10. Sorry, 1 to 11. So let's define I here, which is 1. Now we will write here Now we need to call this function by updating the value of I. Product I plus 1, and we are passing this value of I. Okay, so now this I plus 1 is go to I. Then this I will get here. Now where we need to stop this iteration, we need to write condition using if. If our I equals to 11, then return from this function. Simply just return. Then we will came out as a function and our function will over. Okay, so if I run this command, oh, we need to pass here i's value first, which is 1, or we are not required to define here. We can simply just pass 1 also. Now we got the value multiplication table of 4. 4 is a 4, 2 is a 8, 3 is a 12, 4 is a 16 till 10. Now if I improvise this code, like I can write here also using formatting, I can make a very clear output. Here I can write 4 into I equals to. Now our output will looks good. See, now it is clear that it is multiplication 4 into 1, 4 till 4 into 10, 40. So what is our basic criteria? This is where we have defined our basic criteria. And here we have done our updation of I. Okay. So I hope you understand this example of recursion. Now if I talk about the basic definition of a recursion, recursion is a function is called recurs function is called recursive if a statement within the body of the function calls the same function. Statement within the body of function calls the same function. Okay. So basically function is calling itself again and again till our condition get false. Or also we can write here less than 10. Then also we will get the same result. Why it is not printed? Let's see. If I is less than 10, I should also put here equals to. Oh, okay. Okay. I think we can't do here anything else. Hmm. This is our recursion and recursive function is invoked by itself directly or indirectly as long as the given condition, directly or indirectly, as long as जब तक कंडीशन ट्रू है तब तक हमारा जो फंक्शन है वो इन्वोक होता रहेगा, मतलब कॉल होता रहेगा। अब डायरेक्टली और इनडायरेक्टली का क्या मतलब है वो अभी आपको समझाता हूँ। और ये जो रिकर्जन वाला टॉपिक है ना, ये डेटा स्ट्रक्चर्स में काफ़ी यूज होता है, डीएसए, डेटा स्ट्रक्चर्स एंड एल्गोरिथम, जहाँ पे आपको स्टैक्स होता है, मतलब ये रिकर्जन ना बेसिकली स्टैक्स होता है, मतलब जैसे आप एक गड्डी रखते हो ना बुक्स की, एक बुक फिर उसके ऊपर दूसरी बुक फिर तीसरी बुक, वैसे ही उसको एक स्टैक बोलते हैं, फंक्शन जो है एक स्टैक की तरह चलता है। इसका मतलब ये आपको समझ नहीं आया। Now if I move towards the type of recursion, there are two types. First one is direct recursion. What is a direct recursion? When function call itself directly and in that case only one function is invoked, which call itself. Okay, call itself until given condition, and before that these points are also very important, I should mention it here also. That is our first basic criteria, which is there must be at least one basic condition in recursion process, and when that condition is met, the function stops calling. There must be at least one basic condition in recursion process. When that condition is met, the function stops calling. If you are not if you are not doing basic criteria, then it will become infinite loop. It will recur infinitely. Now recursive step. Now what is a recursive step? Basically updation. Is a recursive step is a recursive calls progress in such a way that each time a recursive call is made, each time a recursive call is made and it comes closer to basic criteria. So I hope you can understand now what this line means. प्रोग्रेस होती है इस तरीके से कि जो रिकर्सिव कॉल है वो उसकी वैल्यू अपडेट होते होते बेसिक क्राइटेरिया तक पहुंच जाती है जिससे वो एंड दी एंड फंक्शन जो है स्टॉप हो जाता है. ओके, नाउ लेट्स मूव ऑन टू द टाइप्स. नाउ देयर आर टू टाइप्स, डायरेक्ट रिकर्जन and indirect recursion. Direct recursion is when function call is directly. Okay, so there is a direct function. And now you can understand what is the meaning of an indirect function. The example I have shown till now are direct recursion. Now second is our indirect. Indirect recursion is opposite of direct here. Two or more function call each other. Not only one function is participating here. Two or more function call each other in circular manner. Okay, so if I give you an example of this type of recursion, suppose I create a function def add I, and I will do print s1 b and return Now here in this example, we have created two functions, product and add. Product is calling add function and add is calling product function. And this is the start of our indirect recursive function. If I run this command, we will get values from 2 to 4, 6, 8, 10, 18. Now what's happening here? We have right basically multiplication of 2 till 9. If I write till 10, then we need to put here 11. Then we will get till 20. Now let's understand what is basically happening here. First, we will move to the function call of product and it is passing value 1 to product function. Then we go to product function. Here I becomes 1. Then we will check that is I is equals to 11. This condition become false. Then we will print I into 2, which is I is 1 into 2. So we will print 2. Now we will call function add I. Here I is 1. Now our add function will take that value I, which is 1, and we will add I plus 1. We will basically updating the value of I. It will update the value of I and then we will again call the function product I. Now you can see that product I becomes 2 now. 1 plus 1, 2. Now I becomes 2. It will pass 2 to the I. I is equals to 11. False. Then we will print I into 2, which is 2 into 2. Then we got 4. Now we will again call add by the passing value I, which is 2. Now this add will again update value of I to 3. Now we will again pass this 3 to product I. Now this loop keeps going on till our I becomes 11. Whenever I becomes 11, we will return to the point where function is called first. This is how we print the multiplication of 2. So this is the basic example of a indirect recursive function. Just see and dry run by yourself this code. Means take copy and paper, sorry, pen and paper to dry run. Go through all the step of this code and try to write the output in paper. Then you will understand it better. Okay. So I hope you can understand what is the example of an indirect recursive function. And one more important line, it is initiated indirectly. Okay. So there are some important points regarding function. Important. First thing, self-calling. Second thing, base condition. Third, function are user defined. Now, what is mean of user defined? So basically, there are two types of function we have. We call what we have two types of function. I think I have told you this or not. Let me just show you again. What is two types of function we have? User defined and we called it inbuilt. Two types of function. First one is user defined and second is inbuilt. User defined that functions created by user. Like till now we have created function with our own requirements. So those are user defined. Till we have created the so many functions and built-in functions are what we can say that basically they are already built. They are already built. I can say we can say a pre-defined function created by created while we can say created by developers for us to use. If I give an example, like we have learned map function, we have learned reduce, etc. So these are the type of built-in function. And user defined are basically what we are creating here. These are user defined. These are created by a user. Okay. Now recursion are user defined. They are not inbuilt. Now fourth is memory is allocated separately. Memory is allocated separately. What does this mean? Means every recursive call get its memory for local variables. These memory is allocated separately. Means every recursive call gets its memory for local variables. Means that whenever there is a call of a function, whenever, how many times, that times our memory is memory is occupied by our function. Basically, it creates a call stack. For example, if I create a container, let's create a container here on. So this is our container. Let's take an simple example of a recursion. We will create a def, then our previous example print num, then if I equals to say 5, then our रिटर्न कर दो वरना प्रिंट कर दो आई को और फिर कॉल कर दो प्रिंट नम by updating the value of I. Now we will print num with passing value 1 and we will get our I. Now this recursive function will print from 1 to 4. Okay, so at 5 it will return and we get our values from 1 to 4. Now let's see what happens. Whenever I is 1, then basically a stack is created for one value. A stack is created where 1 is stored. When I is 1, a stack is created where 1 is stored and our 1 is printed. What has happened? Our 1 is printed. Output is our 1. Now then when I becomes 2, when I becomes 2, then again one more stack is created for 2, where 2 is stored. Now again, when I becomes 3, one more stack is created when I becomes 3 for value 3. and our 3 got printed. 2 will be also printed, 3 also printed. So same as for 4. 4 stack is also created. Okay. Fourth stack is also created. So this is what happened here basically. Here our computer has occupied memories 4 times of equal values. And recursive basically means a stack is created whenever our one recursive call is done. First call is done, one is created and one got printed. And here also 4 is also printed. And when we return, what happened when we return? When we return one by one, this stack get empty. One by one, these all stack get empty. Okay. So this is the basic idea of how recursive call works and how stack is created. So I hope you understand what is the meaning memory is allocated separately. Every recursive call gets its memory for local variables. So what are these I1, 2, 3, 4? These are the local variables because these are created inside the function. If this stack execution order means just I have told you recursive calls gets its memory for local get its memory no recursive calls are stored in the call stack and are resolved in last in first out. Last in first out. Basically, this last in first out is a concept of DSA. If you know DSA, then you can recognize what is this last in first out. What is this? When the stack is created, uh, like first in first for one stack is created, then for two, then for three, and then for four. Four stacks are created. Now, when we do the return, the last one stack is created will be first move out, then second, third, and then fourth. So basically, this same what I told you now. Basically, this means last in, first out. Last in is four. Okay. In last, four is printed. Stack of four is created. And when we came to return, four is returned first. So last in, first out. And sixth important point is Stack Overflow. Now what this means? Stack Overflow means maybe your memory get when your memory get out of storage. That's the condition where stack overflow is. Means you do not have now any more memory to store a stack. When there is a very deep recursion may lead to stack overflow. Okay. So these are the 6 important points regarding the recursion. Now, a last but important example of recursion, which is factorial. What is factorial? Factorial is if I ask you factorial of 3, it will be 1 into 2 into 3, which is 6. If I asked you factorial of 4, which is 1 into 2 into 3 into 4, which is 24. So I hope you have a basic idea of a factorial and how can we calculate the factorial using recursion. First, we will create a function, say fact. Now we have to pass a value. Now basically what we need to do, our, we need to basically print our recursion of factorial. We need to multiply the previous value from the current value. Suppose I is, we need to find factorial of 4. Then we need to multiply 4 into 3. What is the factorial of 4? We can say 3 factorial into 4. We can say that now this is the factorial of 4. 3 factorial into 4 is 4 factorial. Same we use here. Factorial of a previous number means I minus 1. We will multiply it with our current number. Here I will take I equals to 4. And I will call this number, sorry, function by passing value I. But right now we haven't written our base condition. So what will be our base condition? Our base condition will be if I equals to 0 or I equals to 1, then we need to return. Else we need to continue our factorial. Now this is our final program of to find the factorial of any number. What is wrong here? क्या गलती हो रही है? Okay. So whenever I becomes 1, we need to return 1. Cause 0 factorial is 1 and 1 factorial is also 1. Okay, so whenever I will also become 0 after iterating, then we need to return 1. If I run this command, okay, I need to print this, right? Why? Because I have right here. Now we will get our correct output, which is 24. So if again I explain you this, listen carefully. I is 4, okay. Now what is happening here? I is now right now our force. Then we will call and we'll print and pass this 4 to the our function. Then it will check is 4 equals to 0 or 4 equals to 1. False. We will move to else condition. Then it will return. It will again call the function by reducing the value and multiply by our 4. What is happening here? 4 into, it will call, first it will call our function again by updating the value from 4 to 3. Then I become 3. Let me just, it will call first 4, then it will call 3, then it will call 2, then it will call 1. And if our 1 will become 1, then we'll return 1. Return 1. Okay. Now what we'll do, when we return 1 by 1, we will multiply 1 with 2, which becomes 2. Then we will return to 3 from 2 to 3. Then 2 into 3 will do 6. Now when we return from 6 using 6 to 4, then 6 into 4 will become 24. So basically we are first calling the previous factorial. We are getting stack of number from 4 to 1. Then when we are returning, we are multiplying all those number one by one when we are deleting all those stacks. Okay. So I hope you understand. This is all about recursion today. It's a little bit difficult, but it is important. So make sure you understand recursion very well. So this is all for today. Thank you.